Hi, yesterday we studied about various angles that are representing either the x-axis or the y-axis. Let's try to revise a little bit. Positive x-axis is denoted by even multiples of pi, negative x-axis is denoted by odd multiples of pi. That brought us to the conclusion that if we are talking about a horizontal axis, either it will be even multiple of pi or odd multiple of pi. So we can say multiples of pi are going to lie on the horizontal axis. Let's talk about the vertical axis. If I'm talking about positive y-axis, then the angle representing the positive y-axis are going to be 4n plus 1 pi by 2, which can also be written as 4n minus 3 pi by 2. So all the angles referring to the positive y-axis are 4n plus 1 pi by 2 or 4n minus 3 pi by 2. Let's have a look at the negative y-axis. It can either be denoted by 4n plus 3 pi by 2 radians or 4n minus 1 pi by 2 radians. So if we are talking about the vertical axis, the general formula of the angle representing the vertical axis will be a multiple of pi by 2. I hope it's clear till here. Let's move forward, and today we are going to discuss angles. Okay, today we are going to discuss about a new topic, that is going to be unit circle. What do you understand by the word unit circle? Let's say there is a circle with center at origin, so the coordinates are going to be 0, 0. If the coordinates of the center point are 0, 0, and I say that this is a unit circle, what does that mean? Unit circle means a circle whose radius is equal to 1. So if anyone asks me what is the radius of this circle, then I am going to answer it by saying 1 unit. Now unit can be anything, either centimeter or millimeter or nanometer, micrometer or anything. But if it is, the magnitude is 1, then it is called a unit circle. Now if it's a unit circle, I am going to draw a triangle over here. The coordinates of this point are assumed to be a comma b. Let's name this triangle as O, A, B. What is this distance going to be? This is going to be equal to abscissa, that is A. What is this distance going to be? That is distance AB. Now that will be written as small b. This is known as the ordinate. So first we write the abscissa, then we write the ordinate. So let's assume this angle to be theta. In triangle AOB, the angle AOB is theta, the length of AB is small b, and the length small a. Now if we are talking about trigonometric ratios in triangle AOB, then sine theta is going to be perpendicular upon hypotenuse, that is the vertical component upon hypotenuse. As we assume that hypotenuse is going to be 1 units, for the sake of simplicity, let's assume it to be r. Now r can be anything. In this case it is going to be 1, but for the general term we are going to use the variable r. So sine theta will be vertical component divided by hypotenuse. So it will be written as b upon r. Now let's talk about cos theta. What will cos theta be equal to? Cos is the ratio of base to hypotenuse. So base is the horizontal component, that will be A is to R. So cos theta equals A upon R. Now let's talk about tan theta. Tan theta is the ratio of sine upon cos. So looking over here, we can directly say it will be B upon A. But let's use the triangle to answer that question. Tan theta is the ratio of vertical component to the horizontal component. The vertical component in this case is B and the horizontal component is A. So tan theta will be written as B divided by A. I hope it's clear till here. Now we are going to talk about the second quadrant. Let's discuss about the second quadrant. In the second quadrant, I am going to draw a congruent triangle. If I am drawing a congruent triangle, a triangle congruent to triangle A, O and D, the congruent triangle would look something like this. This will be O, this let's call it A dash, and let's call this B dash. If these two triangles are congruent to one another, then the dimensions should be equal. All the sides have to be equal, all the angles have to be equal. This side is going to be analogous to this one. So I am going to call it small b. The length will be denoted by small a. Now the point to be noted over here is the length is a. If the length is a in negative direction, then what is the coordinate of this point? The coordinate is going to be minus a comma 0. Distance is a. But because it is on the negative x-axis, we are going to write it with a negative sign. So it becomes minus a comma 0. The point over here will be denoted by 0 comma b. The reason I am writing 0 first is because of the convention that abscissa is written before ordinate. Now if these two triangles are congruent, then the angle between the base and the hypotenuse in the triangle AOB is considered as theta. So by analogy we can say that A dash O B dash, this angle will also be theta. Now there were two observations that we discussed yesterday. The first one was the angle is always measured from positive x-axis, and the second observation was that anti-clockwise direction is considered positive. So if I am talking about the angle made by the line OA dash, then the angle will be measured from positive x-axis and it will be measured in anti-clockwise direction. If it is measured in anti-clockwise direction, then this is going to be the angle. What we studied in the first lecture of this topic, this entire angle is pi. If this entire angle is pi, I am removing theta from it, then what will be the angle that's left? It will be written as pi minus theta. So the angle made by the line OA dash is pi minus theta. Now let's talk about trigonometric ratios. In this case, we are going to say sine of the angle, that is pi minus theta, is equal to perpendicular upon hypotenuse. That was in the general case, but particularly it's called vertical component to hypotenuse. So the vertical component is going to be b and the hypotenuse is r. So I'm going to write b over here divided by r. If I'm writing b upon r, we can observe b is positive, r is going to be the same because the circle remains constant. So the radius and the center of the circle will also be fixed in both the cases. So I'm going to say sine of pi minus theta is b upon r, and as we observed in the previous case, b upon r, what is b upon r? Sine theta. So I can say sine of pi minus theta can be written as sine of theta. Now let's move forward to the next trigonometric ratio, that is cos of the angle. This will be written as cos of pi minus theta. Let's observe. Pi minus theta is this angle for the line OA dash. If I have to find cos, cos is base upon hypotenuse. So the general term will be horizontal component upon hypotenuse. So the horizontal component is minus a upon r. So this time I am going to write it as minus a divided by r. And as we saw in the previous case, a upon r is cos theta. So cos pi minus theta will be written as minus cos theta. Now let's observe. Sine of pi minus theta was sine theta. Cos of pi minus theta becomes minus of cos theta. Let's examine what happens for tan. If I'm talking about tan, if I'm talking about tan of pi minus theta, let's see. Pi minus theta refers to the line OA dash. If I'm talking about tan, tan is the ratio between vertical component to horizontal component. So the vertical component in this case is going to be small b, and the horizontal component is minus a. So I'm going to write it as minus of b divided by a. As we observed, b upon a can be written as tan theta. So the term inside the bracket will be tan theta. I'm going to write it as minus of tan theta. So now we can say that if the angle is written something like pi minus theta, then sine remains sine, cos remains cos, tan remains tan. But if I'm talking about SIGN sign, plus minus wala sign, if I'm talking about SIGN sign, then we are going to say that this SIGN sign follows LHS. Since in the second quadrant sign is positive, SIN wala sign is positive, so over here I am going to put a plus sign. In the second quadrant cos is negative, so from LHS we are going to put a negative sign. Since tan is negative in the second quadrant, so we are going to put a negative sign over here and call it minus tan theta. I hope it is clear till here. I'll summarize what we just studied. We studied a set of formulas, and the formulas are sine of pi minus theta is equal to sine theta, cos of pi minus theta is equal to cos theta with a negative sign, tan of pi minus theta is equal to tan theta with a negative sign. The trick to remember them is, whenever you see a multiple of pi, the trigonometric ratio remains the same. Sine will remain sine. For a multiple of pi, cos will remain cos. For a multiple of pi, tan will remain tan. What about the SIGN sign? if I'm talking about SIGN sign, this sign, then this sign follows LHS. We can put a note and say that SIGN wala sign follows left hand side. On the left hand side, I have sign in the second quadrant. Since we all know sign is positive in the second quadrant, I am going to put a positive sign. In the second quadrant, cos is negative, so we are going to put a negative sign. In the second quadrant, tan is also negative, so again we are going to put a negative sign. I hope it's clear. Now let's move forward to the third quadrant. If we are talking about the third quadrant, let's make the basic assumptions that we discussed in the previous case. There is a unit circle, center is at origin O comma O. This is going to be my basic triangle. I am again going to name it O A B. Let's the coordinates be same, A comma B. This length will be A. This length is going to be B. This is abscissa, that is ordinate. Let's assume that this angle is theta. Is there anything else that's needed? Now let's venture into the third quadrant. Okay. Now if I extend this line over here, and what am I doing? I'm making congruent triangle so that it becomes easy for me to analyze the two cases. I'm going to draw a congruent triangle. This is going to be a vertically opposite angle, so this will also be theta. The side opposite to theta is B, the length is B, so the length of this side is also going to be B. The side which is acting as the base for the angle is equal to A, so in the congruent triangle this side is also going to be A. We assumed this to be R, so the hypotenuse will remain R. Now let's talk about the quadrant third. In the third quadrant, X coordinate as well as the Y coordinate both are negative. So if the distance is A units in negative X direction, the coordinate will be minus A. So I'm going to write that this coordinate is minus A comma 0. Let's observe the same thing, but this time for the y-axis, and not only y-axis but also negative y-axis. In the negative y-axis, if I am traveling a distance of b units, then because it is in the negative direction, the coordinate will be minus of b units. So I am going to call this point as minus b, 0 comma minus b. Now if we are talking about the first triangle, that is in triangle AOB, what is sine theta? Sine is the ratio of vertical component to hypotenuse. The vertical component is b, hypotenuse is r, so sine theta is written as b upon r. If I am talking about cos theta is the ratio of horizontal component to hypotenuse, so it is going to be a upon r. If I am talking about tan theta is the ratio of vertical component to horizontal component, so this is going to be b upon a. I hope this much is clear. Now we are going to study the third quadrant. In triangle O, this point is going to be B dash. This point is going to be B dash and this point is going to be A. This is B dash and that is A. So in triangle A dash O B dash, if we are discussing about this triangle, let's talk about the first trigonometric ratio, that is sine theta. Sorry, not sine theta. Let's discuss the angle. If this is theta, the angle is always measured from positive x-axis. The two conventions that we discussed were that the angle will always be measured from positive x-axis and the anti-clockwise direction is considered as positive. So if the angle is measured from positive x-axis in anti-clockwise direction, this much is going to be pi and we are adding theta to it. So it will be pi plus theta. So the angle corresponding to the line OB dash is pi plus theta. So I am going to write sine of pi plus theta is equal to sine of angle corresponding to pi plus theta. Okay. Now sine is the ratio of vertical component to hypotenuse. The vertical component in this case is minus b and the hypotenuse is r. So it will be minus b divided by r. As we observed, b upon r is sine theta. So b upon r will be substituted by sine theta. And let's observe in the next case. In the next case, we are going to talk about cos of pi plus theta. If I am talking about cos of pi plus theta, then cos is the ratio of horizontal component to the hypotenuse. The horizontal component is minus a and the hypotenuse is going to be r. as we just saw, A upon R is cos theta. So I'm going to write it as minus cos theta. Now let's observe for the third trigonometric ratio, that is tan of pi plus theta. If we are talking about tan, what is tan? Tan refers to the ratio of vertical component to horizontal component. The vertical component is B, horizontal component is A. Both are coming with a negative sign, so it will get cancelled. I am going to say minus B divided by minus A. They get cancelled. B upon A is tan theta. So I am going to say tan of pi plus theta equals tan theta. This is what we discussed in the earlier lectures, that in the first quadrant all trigonometric ratios are positive, be it sine, cos, tan or their reciprocals cosec, sec, cot. All of them will be positive in the first quadrant. But if we are discussing about the second quadrant, then sine is positive, cos is negative, tan is negative, and the reciprocals will follow them. That is, cosec will be positive, sec will be negative, and cot will be negative. If we are talking about the third quadrant, then in the third quadrant, tan will be positive, sine will be negative, cos will be negative. Their reciprocals are going to follow. So cot will be positive, sec will be, and cosec will be negative. In the fourth quadrant, cos and sec will be positive, sine, cosec, tan, cot, they are going to be negative. So now let's move forward. If you have to use the angle when it says pi plus theta, whenever you see pi, sine will remain sine. Whenever it is pi plus theta, then sine will remain sine. Whenever there is pi plus theta, cos will remain cos. Whenever you see pi plus theta, tan will remain tan. So now whenever the angle is written as pi plus theta or pi minus theta, as in the previous case, sine will remain sine, cos will remain cos, tan will remain tan. Excuse me. And now we are talking about SIGN sign. This SIGN sign will follow LHS. Now SIN sign, it is negative in the third quadrant, so we are going to put a negative sign. Cos is negative in the third quadrant, so we are going to put a negative sign. Tan is positive in the third quadrant, so it will be plus tan theta. Let's quickly summarize what we studied. Earlier we studied the formula sin pi minus theta, cos pi minus theta, tan pi minus theta. If we are talking about pi minus theta, where does that take me? Pi brings me to negative x-axis. If I subtract an acute angle, I enter into the second quadrant. If I am in the second quadrant, only sign is positive, they both are negative. So I'll put a plus sign, minus sign, minus sign. Since they are multiples of pi, sine will remain sine, cos will remain cos, tan will remain tan, and we are going to put theta. So sin pi minus theta is plus sin theta, cos pi minus theta is minus cos theta, tan pi minus theta is minus tan theta. Now let's discuss the next set of formulas, which were for sin of pi plus theta, cos of pi plus theta, tan of pi plus theta. Let's observe. If I am doing pi plus theta, where does pi take me? Pi brings me to negative x-axis. If I am adding an acute angle, I enter into the third quadrant. In the third quadrant, if I am talking about SIGN sign, this sign in the third quadrant will be positive for tan and negative for others. So I am going to put a positive sign here, negative here and negative here. Sine will remain sine since it's a multiple of pi. So I am going to write sine over here. Cos will remain cos since it's a multiple of pi. And tan will remain tan since it's a multiple of pi. Now we can see this is theta, this is theta, this is theta. So tan of pi plus theta is plus tan theta, cos of pi plus theta is minus cos theta, and sine of pi plus theta is minus sine theta. Let's discuss a few questions based on this. Okay, so if I say write sine of 2 pi plus theta, let's observe what is happening. If we are following the long approach, we can say that the angle is 2 pi plus theta. Theta is an acute angle. If I add 2 pi to it, what happens? This is theta. On adding 2 pi, I venture an entire circle, then I add theta to it. So this will be 2 pi plus theta. So as we observe, theta and 2 pi plus theta are the same thing. So the sine of both of them should be equal. So sine of 2 pi plus theta will be equal to sine theta. And the shortcut that we remembered in the lecture today, we can say that since this is a multiple of pi, so sine will remain sine theta, and since 2 pi plus theta brings me to the first quadrant, in the first quadrant sine is positive, so we are going to put a plus sign over here. So it becomes plus sine theta. Let's talk about another case. If I am talking about sine of 3 pi plus theta. Now first let's understand it by the long approach, then I am going to link it with the shortcut that we just studied. If I am talking about 3 pi plus theta, then where does 3 pi take me? Because we know that theta is an acute angle. 3 pi, this much is pi. If I travel 2 pi more, I come back over here. Now after traveling 3 pi, I enter into the third quadrant. If I am in the third quadrant, sine is negative over here. Now this is a multiple of pi. Since it is a multiple of pi, sine will remain sine. So I am going to put sin over here and theta over here. So sine of 3 pi plus theta can be written as minus of sine theta. Now let's discuss this same angle for cos. If I am talking about cos of 3 pi plus theta, 3 pi plus theta, where does 3 pi take me? Negative x-axis, since it's an odd multiple of pi. On adding an acute angle, I venture into the third quadrant. In the third quadrant, cos is negative, so I put a negative sign. Multiple of pi, so cos will remain cos, and I'll put a theta over here, so it is minus cos theta. Now let's talk about tan. If I'm talking about tan 3 pi plus theta, tan 3 pi plus theta, 3 pi, since it's a multiple of pi, tan will remain tan theta. Now 3 pi plus theta takes me into the third quadrant. In the third quadrant, tan is positive, so we are going to put a positive sign over here. So the answer is going to be plus tan theta. In order to draw a bit of similarity, I'll take another example. Let's discuss for sine of 5 pi plus theta. It's a multiple of pi, sine will remain sine. 5 pi plus theta, where does that take me? If I'm starting from positive x-axis, 4 pi will take me back to the positive x-axis. Now after 4 pi, I am again traveling pi radians, so that will take me to negative x-axis. You can also remember that 2n plus 1 pi radians takes me to negative x-axis. So if I travel an acute angle more, I'll again enter into the third quadrant. If I am in the third quadrant, sine of sine, SIGN sine of SIN sine is negative theta. If I am talking about cos of 5 pi plus theta, it's a multiple of pi, cos will remain cos theta. 5 pi plus theta takes me to third quadrant. Over there, cos is negative. If I am talking about tan of 5 pi plus theta, tan of 5 pi plus theta is going to take me to the third quadrant. Tan is positive, multiple of pi, tan will remain tan, and I am going to write theta over here. I hope this is clear. Please note it down. If there are any queries, feel free to comment. I'll answer them. Okay. Now let's discuss the next case, which was sine of 3 pi minus theta. Now if I am talking about 3 pi minus theta, since it is a multiple of pi, since this is a multiple of pi, sine will remain sine. I am going to write sine over here, sine theta. 3 pi minus theta. Let's observe. 3 pi takes me to negative x-axis. If I subtract an acute angle, I'll enter into the second quadrant. In the second quadrant, sine is positive, so it will be plus sine theta. If I'm talking about cos of 3 pi minus theta, then multiple of pi, so cos remains cos theta. 3 pi takes me to negative x-axis. Minus theta brings me to second quadrant. Over there, cos is negative. Let's talk about tan of 3 pi minus theta. If it's a multiple of pi, I can say that tan will remain tan theta. 3 pi minus theta takes me to second quadrant. Tan is negative, so I'll put a negative sign. It becomes minus tan theta. I hope it's clear. Now let's analyze it similar to the last example that we took. Okay, if I had sine of 5 pi minus theta, in this case, sine 5 pi minus theta, 5 pi, odd multiple of pi, takes me to negative x-axis. If I subtract theta, I enter into the second quadrant. Now it's a multiple of pi, so sine will remain sine theta. Now since I'm in the second quadrant, sine is positive, so I'll put a plus sign. if I'm talking about cos of 5 pi minus theta. Cos of 5 pi minus theta, it's a multiple of pi, cos will remain cos theta. In the second quadrant, because I am in the 5 pi minus theta zone, that is the second quadrant, cos is negative. Now let's talk about tan of 5 pi minus theta. It's a multiple of pi, so what am I going to say? Tan will remain tan. So I'm going to write tan over here, theta. 5 pi minus theta, second quadrant, so tan will be negative. So you can see the similarity between the results. I hope that's clear. Okay, let's move forward to the next topic. What if the multiple of pi which we were writing in front of theta, that multiple is 0. If I say find the value of sine of 0 plus theta, what will this be? The angle is 0, I am adding theta to it. The angle is 0 means positive x-axis. If you add an acute angle, you enter into the first quadrant. So this is going to be sine theta. It's a multiple of pi. Since it's a multiple of pi, sine remains sine. In the first quadrant, sine is positive, so it's a plus sine theta. If I talk about cos of theta, I can write it as 0 into pi. So now it's a multiple of pi, so I can say that it will be cos theta, and in the first quadrant it's positive, so I'm going to call it positive. This was a simple case. Now we'll talk about 0 minus theta case. If I want you to find the answer to sine of minus theta, we are going to write it as sine of 0 minus theta. They both mean the same thing. If I'm writing minus theta or if I'm writing 0 minus theta, they both refer to the same line. If they both refer to the same line, I can say 0 can be written as sine of 0 into pi minus theta. So now this is a multiple of pi. Since it's a multiple of pi, sine will remain sine. I'm going to write sine over here, theta. Now let's observe for SIG and sine. If I'm talking about 0 into pi, that is positive x-axis. Minus theta brings me to the fourth quadrant. In the fourth quadrant, SI and sine is negative, so I'll put a minus sign. So now what did we see? Sine of minus theta becomes minus sine theta. So I can say that sine of minus theta is equal to minus of sine theta. This is a formula which will be widely used in maths as well as physics. The way to remember it is that in case of sine, if the angle comes with a negative, you can bring that negative outside it. That is not what's happening. It's a way to remember it. This is how we come to the conclusion that sine of minus theta equals minus sine theta. The way to remember it is that in case of sine, you can bring out the negative term. Now let's discuss the same thing for cos. If I ask you to find the value of cos of minus theta, then this can be written as cos of 0 minus theta. 0 can be written as cos of 0 into pi minus theta. Since it's a multiple of pi, cos will remain cos theta. Now let's observe for sine, SIG and sine. In the quadrants, I can say that 0 into pi brings me to positive x-axis. If I subtract theta from it, I'll enter into the fourth quadrant. In the fourth quadrant, cos is after school to coaching. C is positive, cos is positive. So I'm going to put a positive sign over here. So the result is cos of minus theta equals cos theta. And this is the another widely used result in maths and physics. Cos of minus theta is equal to cos of theta. The way to remember it is that whenever cos has a negative angle, then cos consumes the negative. Cos consumed the negative, so we got cos theta. It's a way to remember. Actually, this is the reason why cos of minus theta equals cos theta. I hope that's clear. Now let's discuss the same thing for tan. If I have to find the value of tan of minus theta, I can write this thing as tan of 0 minus theta. 0 can be written as tan of 0 into pi minus theta. So now since it is a multiple of pi, tan will remain tan. I will write theta over here. Let's observe the quadrants. 0 brings me to positive x-axis, or we can even say even multiple of pi brings me to positive x-axis. Minus theta, clockwise direction, I have an acute angle, so I am in the fourth quadrant. Over there tan is negative, so I'll put a minus sign. Ultimately we can say tan of minus theta equals minus tan theta. So this will be the final result. It is similar to sine. Another way to observe this is, if someone asks you to find the value of tan of minus theta, just write it as sine of minus theta divided by cos of minus theta. According to the previous two cases that we recently discussed, sine minus theta, I can write it as minus sine theta divided by cos consumes the negative, so I'll write cos theta. This becomes minus tan theta. So now tan of minus theta is minus tan theta, and tan of minus theta is minus tan theta. You can use either of the two results, but the important point is that you must know what is happening in each individual case. Now your homework is to do the same thing for sec, cosec and cot. I hope you will be able to do that. Thank you.